Hello again. So firstly, we will start by creating our environment. So let's drop in an empty geometry node. Let's call it environment. I'm going to create a little network around it. And let's name it step 1 environment. Can make it something like green because it's the land, I suppose. Let's dive inside and then start by creating a height field. It's going to be 1000 by 1000, and we're going to leave the grid spacing to 2 for now. Let's drop in a height field noise. Okay, gives us a nice random noise. We're gonna change the settings now according to my other scene to match the shape. So element size 1000, amplitude 912, scale 0.3, 0.3, 0.3, some spiky environment. Okay, and sparse convolution, hybrid train. I think everything else is the same. Yeah, and then we're just gonna put a erode, and we're gonna erode it to frame 985. Under the advanced tab, we're gonna change the seed to match the current seed that I have, and everything else should be same. So if I plug this in, we need to, our frame range is correct. Let's change our max frame to 950. We start from 950. So we do a pre-roll from 950 to 985. So start frame, we're going to change it to 950 as well. And I think that's it. So let's plug this guy in, and now it's gonna post roll to 985. Where I'm gonna pause the video. Okay, so now this is our current shape. So it was like this, and now some erosion, so it gives a bit more natural look. And I don't want to do much on top of this, so I'm just going to convert this to now polygons. We don't have to convert this to polygons to use as a collider, but I'm doing some post work on it. That's why I want to do that. So and then let's create some normals, because we're gonna do some warp operations on top. Okay, and then what I want to do is I want to blur the normals. So to do that, I'm going to use attribute blur, and I'm going to blur the normals by 20 iterations. So if I wanted to visualize that, I think we could probably see the blurred normals, but so it's okay, sorry, this needs to be point. This to work. So the normals needs to be added to the points. Okay, so what happened is, because I want to add some displacement using the normals, and the current normals here is it's some places that are too jagged, right? So what I'm doing is basically I'm smoothing this geo out. It's almost like if I had a P, and I'm using like pretty much the normals of this geo, but instead of instead of blurring the position, I'm just blurring the normals, and it's just kind of giving me blurred out normals, which you can see from the look of it. Okay, now I'm going to create a point. Well, to do my displacement. So what I want is, so let's call this displace geo. So all right, so our mesh is ready. What we want to do is to put down a turbulent noise and adjust the settings, frequency X to be 0.02, Y to be 0.05, Z 0.02. I'm just going to increase the roughness to 0.6 and turbulence to 6. Alright, so one is the position. We need to link position to position, and then I'd like to fit this value from 0.05 to 0.5. Actually, let me plug this in after to show why, to show you why I'm doing that. And then I want to put displays along the normals, and what I want now is my noise to be connected to my amount, and what I also want is to connect my output to my position. So I'm just making sure the flag is correct. Actually, I'm gonna put another normal right under so we can see the fixed result out of the box, because without the normal we won't, with the smoothed normals we will not see it. Okay, so what I want is basically I want to create extrusions that we can see. Actually, let me just go to the video to show you what I mean, what we're trying to do. Where am I? Here. Oops. Here. So I think we can see it here. Yes, okay. You see how the it's almost like, because usually when waves, when rocks are hit by waves, you know, they create these like a bit lateral cavities. So what I want to create is these extrusions, displace the faces on single, everything except the y-axis pretty much, so they get pushed out. So that's why we're doing this section, just to create a bit of a more natural rock formations, I would assume. So okay, so then what I want now is, I have my smooth normals. What I want is that I want to get down a node vector to float, connect my current normal to this guy, and then float to vector, connect. So this is gonna zero out the y-axis, and then I can connect this to the n. So then in my displacement, I can scale this guy up, and as you can see, it's going outwards. So the value is 12. But obviously we're going to need more detail. And then what I'm doing is that to play with the results, I'm putting a fit, which my current values are 0.05 to 0.5. Okay, so this is going to give that extra touch, which we will need to upres to see further detail. So there's a more cleaner way than doing this, but the reason I do it is like this is sometimes I manipulate this data on X, Y, and Z. But if you don't need to do that, I think the node was called get vector component, and vector component 2, you want it to be 0, so we go n, and then this goes as n. Oh, maybe get vector component 2. Well, actually I'm not sure. This should give me component 3. I want to set one of these to a 0. Actually, let's plug this in here to check the values. So this guy, CD, it just outputs a single one, so I don't think there's a one that multiplies. Okay, so yeah, okay, so this one gives either 1 or X or Z, it equalizes it. I don't know if there is actually one. Get vector to, okay, maybe there isn't, so maybe what I'm doing was already correct. So I'll just plug this guy here, and I don't want this to affect the color. Okay, and then I'm gonna bake this. But before we bake this, because we were working on a lower res version now, what I'm going to do is that we're gonna change the height field grid spacing from 2 to 1 to get further detail. But as soon as I change that, this will start calculating. I think this needs to be reset actually. Height field, yeah, okay, yeah, this needs to be reset because it's sim. So then this is gonna probably take a few minutes. So I'm gonna reset this, pause the video, and come back to it once it's finished. Okay, so now it's finished. So it used to be like this, and now it's like this. So this guy should give us more detail once we convert that, and then okay, so we get some ins and outs. I wonder if I went actually higher res than this. Okay, well, it's much more in line now of what we want to do. You can just keep pushing this. This is just gonna work fine. You can also use like once you get this guy, I think, out, there's a height field slice tile slice node that, no, not this one, sorry, tile split, right? Yes. So this guy can give you smaller chunks of your tile. So this one will basically divide the height field into 16 sections. So if you need to go really high res on converting this to an actual geo, that's the way to go. I'm not sure, but I think if you do this after the yeah, you should probably do this after the height field era to do whatever you need to do, because otherwise the edges probably won't match. Okay, so right now this is only 1000 by 1000 voxels. That's fine. Okay, so we have now a new geo that has more high resolution. You can further increase this if needed. Okay, cool. So now let's drop in a file cache node. And I am not using file cache 2.0 here because this is something that I'm going to show how to do from scratch, completely in Python and Hython. Super exciting, but we'll get there. For now, it's not necessary. Okay, let's call this Rocks Baked, and we're gonna save this under anywhere you like, but I like to change these to just the way I usually work. Yeah, is like this. So this is a static geo, so I'll just call it static under $OS, so it will be much easier to follow. And you want a single frame, cache it out, done, load, done. Okay, so now what we want is the geometry you'll have is going to be actually higher res than this for final render, which for the end of this tutorial, for this episode, I'm gonna boost this up to 0.5 or maybe even more until I'm out of memory to get as much detail as possible from my machine. So now since okay, so right now end of this line will be our render node. So I'm just gonna put a null here, give it a black color, and call it out render. Okay, cool. And then now obviously we want to make optimized versions of this, and so what's gonna happen is that we're gonna do another branch for creating VDBs out of this that is more simulation friendly. So for now this section is complete, so we're going to create another network and call this, maybe this is the color actually I used, we'll call this environment rocks. And now let's create a polyreduce from this guy. And maybe go 60% on the settings. Well, this current with the grid spacing of 1, it's already good enough. It's not that high res, but because what we want to render, we want it to be much better than this. All right, so I'm gonna put another normal swap because I just want to be clean. I don't know if it's even doing anything, but it's just better. Okay, so we have all this stuff that we don't need. Attribute delete, because this is a static geo. It's not going anywhere. Maybe I'll put the normal after, not to delete it. Okay, so we just have normals and position. And I'm going to copy this guy, paste it here, pasting it. Why is it taking so long? Okay, things happen sometimes. All right, let's put this guy here. Let's call it Rocks Baked Proxy. And let's cache it out as well. And let's copy this now, and let's call this out proxy. Well, let's just call it proxy geo. Okay, and now what we want is to create a volume out of it for volume simulations, wherever we might wanna simulate this, and we're gonna need that for probably ocean water anyway, to float our particles. So now we're gonna create an extrude volume from this guy, and we're gonna plug it right here. So this usually might take a while based on the resolution of the geometry, but for now it's fine. It's fairly clean. And now we want to convert this to a VDB. Let's put this guy here. VDB from polygons. Let's change the resolution to 0.2. It's a fairly large surface. Oh, that's not where it goes, sorry. To the first input. It's coming. %, 45%. It's a bit slow. So this way now we're going to have our render node, collision as a geometry node, our low res node, and the VDB. So this is the VDB. It's fairly good resolution. So even if we had the high res version, it's gonna hold. Let's cache this out as well. So I'm just gonna put this on manual, bring this guy here, rocks baked VDB. Okay, so let's just save that as well. Just gonna redo the thing, which is a bit strange. And then right after that we can move on to the shading of this. I have a few nodes for this that I the texture, sorry, for this that I downloaded and from just Google, and we're gonna use the UV Tri-Planar project to project these textures, so it has some kind of variety. Obviously you guys can do better work, maybe painting something on top would be nice. Okay, so let's create another null node and let's call this out collision VDB. Let's make this guy black again. So let's line these guys up so it's all nice and dandy. And let's put this section in another network and name it environment collision prep, and let's give it a different color. All right, so this is our, all right, we need to go here, sorry. All right, so this is our geometry. Now we need to, let's go one of those far shots, far angles. Okay, so let's look into the shader generation of this now. So what I want to do now is, this is the shader, so we need to go to material network, and inside the material network we can create the principal shader core, no, basic. Okay, I'm just trying to remember the name of the principal shader. I use a classic shader, but there's a template. There used to be a template. I'll try to find it now. Shader. There's so many nodes, I forget. Let's go network. No, it's not network. Alright, doesn't matter. Let's drop in a classic shader, and if you remember, we'll put it in a purple place. Okay. So what I want now is that I want to bring in a UV triplanar project. So this is going to use 3 axes, and it's going to, based on the axis and the angle of the normal, it's going to basically put, it's going to auto UV it for us, and it's just going to project instead of having UVs, because we don't have UVs. So now I might need to copy those textures. Let me quickly do that. Okay, so I need to show you how to do this, guys, as well. So I'm just going to copy these first to where we need it, which is here, our project, on the text, paste it. So these images I downloaded from Google. It's just a bunch of rock textures. They don't tile, so ideally it will be cooler if you guys have some Photoshop skills to tile these up. And now what you need to do though is, after you get these textures, it is always ideal to convert them to RAT or to PIC using mplay. So you see every renderer has their optimized texture format, and Houdini has the same as well. So the way to go with this is, because there's only 4 of them, so there's no need to go to cops and or write some complicated Python for this. So you just go to your folder on the text, rocks. We have 4 of them. I load these JPEGs. They'll show up here. Then you go file sequence as, where am I? Hip, text, rocks, rat, and you just select the name and then accept it, and then you just change the format to rat here, and we're done. So these are the most optimized ways to go. All right, so what I want now is, I'm just going to disconnect this guy. So let's do a render. I have lights in my scene as well, right? So what I want now is, I'm going to put in a render view here halfway through. You can do that by pressing that plus button. Render view. Okay, so we have the render view. I want to render from camera 40. Actually, you know what? Let's first maybe find a camera like this so we see much more. Let's create a new camera. This is cam 1. Let's go to material. So how do we do this? Let's do a little quick render. We might want to just, that's fine. Okay, so this is our environment. Render it gray. All right, so let's just focus on a smaller area. Okay, so now what we need to do is to assign those textures to these axes. So for X, I used, actually what we can do is that we have these tint colors. So if I plug this to diffuse color, and let's name this shader environment, so we can see the separation amount. And let's assign the shader here, and now we should see like RGB coming in here based on, it's gonna tint based on its values. Okay, you see blue, red, and green is like this, normals pointing up. So now I'm gonna change these values for X. I'm going to bring the mask sharpness to 0. Okay, maybe I'm just gonna pause it and then do it, so it's a bit more interactive. So my scale value is going to change, but I'm okay with that now. Well, actually, let's just do that as well. 0.04. Well, we'll do that after we assign textures. Okay, so with angles, we can play on how much we want this to spread. So Y, mask sharpness 0 as well, and Z as well. And now go back to X and click on this guy, go to text, rocks red, and click on show sequence as one entry. So it's going to separate the files, and choose number 4. And then go to the Y-axis and also turn off tint with color. And then go to Y-axis. And on Y-axis choose number 1. And then go to Z-axis and choose, well, number 4 again. Okay. So I'm using 2 textures. So initially these textures, because now it's gonna just project the whole thing, and it was making way too big. I'm not seeing the textures. Okay, that's strange. Or they're scaled too many times. Maybe they are. Let's try to make them bigger. No, that's not it. Just a second. Let's go to x-axis. 0.04, 0.04, 0.04. Y-axis. 0.02, 0.02, 0.02. Z-axis. 0.04, 0.04. Oh, I think, yeah, that should be it. Let's kill the render. Let's do another render. Okay, as you can see, it's tiling a lot. So we want these to be probably bigger. So let's go 0.05, 0.05, 0.005, and maybe for x-axis 2, 2, 2, and let's copy these values because we're using the same texture to here, and let's do another render. Okay, slightly better now. So you see, based on the normals, now it's distributing different areas. So the other thing I want to do is that I want to show you guys how the occlusion shader works, because we got to do some kind of weathering. So I'm gonna put occlusion shading utility node here, and I want to say maximum ray distance is 1 meter, and number of samples is just for creating a bit just to speed up, and then we can also limit based on object selection. So what I want to do is now, instead of plugging the textures to diffuse color, I'm going to plug this guy. I'm going to hit the render, and this should, well, actually, you know, so we can compare, let's do this first, and then let's snap that, and then let's go connect it to diffuse color. So this should give us some, maybe we need to go shorter on the ray distance or longer. That should soften it out. Let's go smaller. Okay, well, it should give us darker areas and where we have occlusion basically based on normals, but I might have to, do I have to bring the normal? Let's bring in the normals. Global variables. I don't think it's next here, but well, maybe we have enough curvature, so maybe let's get closer to a cam 40. Okay, let's do a gray render now. Again, I don't want to spend so much time on the shading part of it, but still nice to have a nice background that has some nicer look to it. Okay, let's close this. So I'm gonna plug in diffuse color here. I'm going to remove this guy, and well, I mean, this should work actually. One second, because I'm a little annoyed with that. Yes, it's called Material Builder, so we're gonna do that in here, so it's easier to control. So we'll call this environment. Okay, so I'm just gonna ditch this guy, cut this guy, put this here, and maybe get this in here. Now we can make our own. Okay, that's just gonna be easier. And so let's start with the occlusion. So let's plug this straight to the color, no lighting information here. So then we should see if it's working or not properly, if there's any effect on it. Oh, maybe environment 1 is not assigned yet also, because we changed the name. This is the shader now, we want to see. Okay, so if we want to change the distance, okay, so now I'm limiting the ray distance, so we are getting just the really in and out areas, getting the occlusion, so we just don't need so much detail. I'm just gonna go 64 so that renders a little bit faster. And the other thing I forgot to mention is that once we have enough high res, we can turn that off, but now we don't. So I'm just going to turn this on, so it's going to subdivide before it renders. So it's going to smooth out all these jagged edges properly, which means that it's going to take a little additional time. So okay, so now we see what's happening here. So let's just increase our depth a bit more, so we start getting more occlusion here and there. Even more, we can go 10 meters. Okay, so we got some more. Now what I want is that I want to multiply this value by 2, so I'm going to put a multiply constant. So I get more brighter areas, darker areas, and then I would like to create a PBR diffuse node. And now the output of my UV triplanar is going to be connected, to my color. And then I want to multiply these textures with this occlusion layer. And then I'd like this to be my Fresnel. Oh, sorry, not really. We want to, because we want to compute the lighting, and that's just like a very basic intro to shading as well. It's a very simple shader now, but then we drop in layer to layer. Let me pause this render. And then I love it about how Houdini doesn't crash when I do that. And then CF to CF, Alt F. We don't really have opacity, so for now it's fine. And if I render now, you should get the textures and the occlusions on top. Okay, I think we forgot the tint somewhere on this one. The blue one? Yeah, we forgot. Okay, so we don't want the tint. Alright, so we have like these three textures that is really working fine now, except that we can't tile them because they're not tileable, but it's much better than what it used to be. So for now, let's just turn off the mantra render polygons as subdivision surfaces. So just the render starts much faster. Okay, and now what we want is, because it's an underground, it's under the water, we can utilize these textures that we have more. So let's create maybe a little bump map, but let's turn on our distant light first, and let's do a test render with our distant light, because that's going to create the shadows. Ultimately, I went for a overcast render, which we didn't have the shadows, but okay, let me just see, where is the sun here. So it's supposed to be there, 40. So if I turn this guy, something like that, and then I guess go 0.5. Okay, so it's there. So let's render. So I get some sunlight just for the shading tests. Okay, so we are receiving some sun now. Let's go like this. So we focus on a smaller area. Let's go back to the shader. Okay, now we want to introduce some speculars, obviously. So if you hit tab under the BSDF, we have the PBR reflection. So I'm gonna put this here. We're gonna reflect. We're gonna add this on top of the diffuse. So it basically just goes like that, and this goes there, and maybe in between we should stop that. Okay, go here. All right. So we can then probably say don't reflect so much. Have quite a big roughness. Well, let's say start with 5. And if I hit render, you should start getting some speculars. Okay, so it's almost like a wet rock now. And now the other two things we can do is that, just to get a bit more complicated or complex, we can drop in a luminance node and plug our output of our projection, and then plug it to our bump to create fake bumps. So I guess we can create displays along, I don't know, was it bump here? Bump to normal map. So we can plug in, no, it's not like this. We are using, because we're creating the shader from scratch, actually we can, I guess, do displays along normal, displays P, and this goes to amount. Let's just force it now really high. Waiting for the result to see if it worked. I think it did, but it's probably too much. Oh, we forgot to save. To do the comparison. Okay, let's unplug that. Okay, let's render it again. Okay, let's capture that. Anyway, 10 was too much. Let's go 2. Plug it to N. We're not gonna actually displace it. Just gonna use it as a bump. And waiting for it to render. Okay, so we got some extra detail, but now we need to I believe we need to get out. Okay, this is actually displacing it now. That looks pretty cool. It's adding a lot of detail, but it might slow us down. So I think we need to go on the environment and then go to gearbox, possibly type displacement here. Displace. Okay, that should bring us all the mantra related displacement information. So you can take shaders, I think, because we're gonna need, we don't need this guy, we just need this guy. So let's push these onto the object level, so they should show up under here. Okay, so it's true displacement, that's why it's displacing it now. I don't want displacement, although I might just keep that because these are looking really cool. It's much better than before, but then this will cause us problem when we do the water sims. So maybe just turn that off, and this should now apply as a bump rather than actual displacement. We'll see now. Well, the silhouette hasn't changed, so I guess it's working. Okay, we might say it's a bit too strong still. Oh, but it's breaking the speculars quite nice. I think it's still too strong, so let's go back to the our shader and maybe put it to 1. Okay, I think that'll do. Okay, so it's better than before. With a higher res, it's gonna look much nicer. So if I now select a better camera, let's just run the whole thing maybe. Okay, cool. We have some good detail. We pull out to our camera, camera 1, render. Okay, so what I'm going to do now is that I'm going to pause the video. Let's render from Cam 40 with this current settings. Now I'm gonna pause the video. I'm gonna change my height field grid spacing to 0.5, and then I'm gonna generate this whole new render mesh that has the higher resolution. So I'll just basically try to capture a lot more detail around this area so we can have much nicer ins and outs than this choppy geometry. And then with the result of that, we're going to conclude the terrain part of our tutorial, and then we will start moving on to our ocean surface. All right, I'm gonna pause the tutorial now, and I'll get back to you once the next render is ready. Okay, so now this is finished. It's with the resolution, where is it? High field resolution with 0.5. So I think now we have enough detail before displacement. So you can even add some displacement on top of this for all the close-ups. But for now, that's good enough. And don't forget to bake the high-res and the low-res versions as well for the VDBs and everything. So you just get a bit more accurate resolution out of this. All right, so so this concludes the making of the terrain for our tutorial, and now we have much nicer terrain. All right, thank you for watching. We will continue with the ocean preparations in the next video.